Here we are, ready to go. Cleared throat, hopefully, and let's see where we end up. So, our very first question asks us for which values of x is m, the expression as it sits over there, undefined. That's for A. Well, for an undefined expression, we understand that we are not allowed to divide by 0. Therefore, x plus 1 cannot equal 0. Therefore, x cannot equal negative 1. We transpose this in the same way we would do a normal equation, and that's what we end up with. Or we can just simply state that for x equals negative 1, given the way the question has been asked. Now, for which values will m be non-real? Now, we know we cannot have the square root of a number where x would be less than 0. We can't have that because that gives us an unreal or non-real value. Therefore, we know that x minus 3, because that's what's under the radical over here, cannot be less than 0, or x minus 3 must be greater than or equal to 0. So, for which values is it non-real? Well, that's for any value that's less than or equal to 3. So, if we redo that properly, x minus 3 less than or equal to 0. So where x minus 3 is less than or equal to 3, again we just transpose the 3 by adding 3 on both sides. So for those values, this expression, this entire expression will be non-real, and given its mark allocation, it's pretty simple to figure out. You just need to know your number theory, guys. Next, express 0.45 repeating as a common fraction. Now, for these ones, first we'll introduce a variable x, and we'll set our value equal to that variable. So let's just expand it using ellipses. So that's what it means, 0.454545 up until forever. Well, why would we do that? Well, we need to multiply this by 100, and then that becomes 100. X being equal to, well, if we multiply by 100, we just move the comma to the right, and that becomes 45, 45, 45, and so on and so on forever. Now, of course, we want to subtract our original x value, and that means we'll have 0.45, 45, and so on. Now, under our subtraction, what we can see is for every column we will end up having a 0 if we subtract the bottom half, and then 45 minus 0 just gives us 45. Well, what about the left hand side? Well, 100 minus 1 is just 99x, and then to resolve this, we know we have to divide both sides by 99. Therefore, x is equal to 45 over 99, and that makes it a common fraction as required. As for our mark allocation, doing our setup, our simplification, and our final answer gives you the full 3 marks. Well, let's get to some factorization. First, well, that looks like a common factor would do the trick. Firstly, we look at the coefficients. Well, 2 goes into both of them, and then as far as the variables are concerned, I can take out an x, and then what's left? Well, when I open my bracket, 2 divided by 2 gives me 1, and x squared divided by x is none other than x. And then if I divide negative 4x by 2x, I get negative 2, and that's fine. That's worth a mark for each factor. Well, under trinomials, well, I can see I have 1 over here, the factors are 1 and 1. which means this one is quite simple. I will have m minus 1, which is just m minus 1 all squared. That is good enough, or you can convert it into that. Well, as soon as I see more than 3 terms in an expression, it's more than likely a grouping that's gonna resolve it. And in this case, we can see that that makes a decent grouping, as does that. Well, if we have a look at our first grouping, we can take out a t as a common factor, and we will have x minus y. And the second one, we need to be careful. I'm going to take out a minus m, which means this needs to become minus y, and to get back that negative, that will be a positive x, which is fortuitous, because all that's required is a little rearranging. In the second bracket, that becomes x minus y. Now, just a word on this, there will be no mark for this. This rearranging can be done mentally, and the step is actually a bit unnecessary, but that is just what it is. Now back to regular programming. X minus y between brackets over there now becomes my new common factor. There it is. And then what's left over here, a t, and in the second term a negative m. And there I am done with my factoring. So how does the mark allocation work for that? Well, 1 mark is for your actual grouping, then taking out a doing the factorization. Okay, so there's a mark for doing this grouping correctly, and then your initial factorization, and then the final factorization. Okay, moving on. Now we're being asked to simplify. Well, let's have a look what's going on here. What's the easiest thing to do? Well, the bottom sorts itself out, because we can see, well, 7 to the power p forms a common factor. Well, at the top, I'm going to need to play around with my exponent. So that's 7 to the power p. And then what I can do is have 7 to the power p and 7 to the power negative 2. What have I done here? What have I done to this term? Well, I've just reversed the first law, which states that, well, a to the power m plus n comes from a to the power m multiplied by a to the power n. As we can see, we have common bases being multiplied, therefore I just add the exponents. But I can reverse this process as done here. So this addition is p minus 2, and there I can see I have p and I have minus 2. So I've just reversed law 1, which is completely legal. At the bottom, well, I can take out the common factor as I alluded to previously. And then what's left? A 3 from this term and minus 1 from the second term. At the top, I can now do the exact same thing, which gives me 7 to the power p. And then I have 1 minus, well, if I use my definition, I can just make that 1 over 7 squared, which is 1 over 49. And then I'll have 7 to the power p, and that's just 2. Well, there we go. Well, 1 minus 49, I can change the 1 into 49 over 49, because anything divided by itself is 1. And 49 minus 1 is just 48 over 49. And then divide that by 2, which will give me 48 over 98. For those pondering how I got to that 98, let's just investigate that. That's going to be 48 over 49 divided by 2, which is the same as 48 over 49. Ooh, I can make a better 9 than that. Multiplied by a half, and we know that we multiply horizontally in that direction, so that's 48 49 times 2 gives us that 98, and I can simplify this even further. That's just going to be 24 over said 49 if I divide both by 2. Yeah, or if I take out the common factor of 2. As far as the mark allocation goes, let's have a look at what the trusty memo says. Well, there's something there for simplifying and factoring, and then obviously for your final answer. I know it's a bit stingy, but these things happen. Rightio. Next. Well, complete factorization required over here. So let's get to it. Well, for the first one, we'll have 12 over x plus 2, x minus 2. Because that is the difference of squares, we need to reciprocate. Which means that goes up and this comes down because it's division sign and we don't want those. Well, the top, that goes to the top, p squared plus 4p, p squared plus 4p plus 4, but I can factorize it in the meantime. It's just going to be p plus 2, p plus 2, and this cannot factorize. It's p squared plus 2p plus 4. That's all multiplied. Now we can't do the reciprocation again, it's already been done for this factor. For the final factor, we'll have the difference of cubes at the top, which is x minus 2, and we need to square that for the first term in the second bracket, which is x squared. We square that for the final term at the back, which is plus 4, and then for the middle term, it's just minus 2 times x, but change the sign, that becomes plus 2x. It's all divided by 4p plus 8, but I can take out the 4 as a common factor and alternate it with p plus 2. Now we investigate for any terms that can cancel out. Well, x minus 2 and x minus 2 divide to give us 1. We'll have p plus 2 and p plus 2. 4 goes into itself once, goes into 12 3 times, and then let's have a look. Anything else that cancels? Nope, nope, nope. So we do not force anything. So that's 3 times p plus 2, and we'll have x squared plus 2x plus 4, all divided by x plus 2 p squared plus 2p plus 4, and then the mark allocation goes along with most of the marks for factoring, as well as the reciprocation. And then the final mark, I'll have a little extra word over here. I specifically altered the sum so that it gives such a complex final answer to teach you one lesson and one lesson only. Do not force cancel out. So most of us can see if this x at the bottom happened to be a p, then those two factors would have cancelled out, and if I had written this in terms of p, then those would have cancelled out. However, you cannot force the final answer that you want. You have to be happy with the final answer that the expression gives. This becomes more important as we go on with our FET mathematics. So, wasn't trying to trick anyone. That was just a little extra lesson in there. Anyway, on to equations and question 2. Well, first things first, this is exponential because we have a variable in the exponent, which means we don't want the 0 on the other side, we want an actual number. So we are going to transpose the numbers that we have. So first things first, let's add 192 both to the left and right hand side. So this then becomes 3 multiplied by 2 to the power q plus 1 being equal to 192. We can divide both sides by 3 because there's a coefficient here that we don't want. That means 2 to the power q plus 1 is equal to 64, which you know is just 2 to the power 6. Therefore 2 to the power q plus 1 is equal to 2 to the power 6, and we have what we wanted, the same basis, which allows us now to form a new equation using only the exponents. Q plus 1 equal to 6. Subtract 1 from both sides. We find that Q is equal to 5, and that is good enough. Oh, what is our U? Yeah. Well, apparently that's just 3 marks. 2 for simplification, 1 for your final answer. Moving right along. I think yellow is a good color. Well, this is just a basic, very basic inequality. What does it state? Well, 3 minus 2x is greater than negative 7 and less than or equal to positive 5. We treat it like any equation, so we'll just add 3 to the inequality right through, or no, scratch that. We are going to subtract 3 to the inequality right through. As such, this becomes negative 10. Well, the whole point was to get rid of that 3, so now we have a negative 2x over there, and that becomes 2. Next up, we will divide the entire inequality by negative 2. Well, what does that do? Well, negative 10 divided by negative 2 gives us 5, and that was the point. Remember, we can divide by negative 2, divide by negative 2. The point was to get x alone, and then obviously over here we have negative 1. But we must always be careful. Division by a negative causes the inequality to flip. Now, this is sort of semi fine, but we always want our smallest value on the left and our biggest value on the right. So this is not flipping, it's merely turning it around so that it looks like a conventional inequality, and that is as good as that gets. Looking at our mark allocation, well, the simplifications and calculations over there garner 2 marks, and then obviously making sure that the inequality is stated correctly with the flipping is the final mark. Hope that is good enough. Next, hey, fractions. No need to be scared. No need to be scared. Well, we have a trinomial over here. We know what to do with those. We can factor. And then over here, we can also do some common factorization. So let's see where that leads us. Well, we'll have d plus 2. This expression in the denominator factorizes to, well, d minus 4 d plus 1. We can add, and then we can take out 4 over there as a common factor, and then we'll have a d plus 1. All I did was flip them around. And then on the other side, well, there's literally, quite literally, nothing to do. Well, now we can work on our lowest common denominator or lowest common multiple. Well, we can see 2 denominators have a d minus 4 and 2 of them have a d plus 1, and then there's also a 4 to consider, and those are the components that we need to make an LCD. D plus 1 is the final part, which means we can now forget about all the denominators. Just make sure that the numerators are adapted accordingly. So for the first fraction, we had d plus 2. Don't forget to put that in brackets. And that must be multiplied with a 4, so that it matches our LCD. So now we'll add it. We'll add 2. Well, this fraction already has a 4 and a d plus 1. What does it need? It needs a d minus 4. So we'll multiply it with that, and that's equal to 3, which already has the d minus 4, but we need the d plus 1 and the 4, so that's multiplied by 4 times d plus 1. Close the bracket correctly. Now it's a case of just simplifying, so we'll have 4d plus 8 plus 2d minus 8 all equal to, well, that's just 12. Well, that's 12d plus 12. Let's see if we can simplify. Well, 8 minus 8 is 0. Because this is linear, we like to keep the number 12 on the right hand side, and then on the left hand side, let's see what we have. That is just 4 plus 2 is 60, minus 12 on both sides, minus 12d, so that zeroes out, and then that's minus 12d. That's why we get minus 6d on the left hand side. Obviously we'll divide both sides by negative 6, which gives us d being equal to, drums please, negative 2. Let's see if we can get a mark allocation that makes sense. Well, for factoring and getting our LCD, we'll get a mark, and then for simplifying and our final answer. And I will also acknowledge that this mark allocation is a bit stingy in the way I set it up. Possibly an extra mark could be allocated. Don't take my word for it. Right. Simultaneous equations. Well, a rewrite is always in order. However, if you want to take care of our spatial requirements, I'm just going to label that equation number 1, and then I'll label this one number 2. Now, first things first, we don't like the fraction over here, but it's an easy fix. So from equation 1, we'll just have minus 2x minus 3y divided by 2 equal to 5, and then we'll multiply both sides by 2. So that gets rid of this denominator. If we multiply by 2, what we do on the left, we shall do on the right. That is the law. So we are left with minus 2x minus 3y equal to 10. So that gives us equation 3, because it's now been slightly adapted. Now the reason for that was, I saw this a negative 3y in the one equation and a positive 3y in the other equation. Now let's transpose equation number 2 over here, and we'll have minus 4x plus 3y equal to negative 4. So that's still equation number 2. I haven't done anything to it. So as I previously stated, I saw that, which means if I add them up, they add to 0. And the point of any manipulation of a system of equations is to get rid of one of the variables to solve the other one, and then you use that result to get back your original variable that you got rid of. So in this case, we're just going to state to ourselves that we are going to add equation number 2 to equation number 3. So minus 2 and minus 4 gives us minus 6x. The point of this was to get to 0, and 10 minus 4 is none other than 6. Therefore, if we divide both sides by negative 6, we'll have that x is equal to negative 1, and that's a cool result. It's not the only one we need though. Then we can use equation number 3 or equation number 2. So we'll sub x equal to negative 1 into why not 2? So that means we'll have minus 4, do our substitution into x, times minus 1 plus 3y being equal to minus 4. That's actually positive 4, because a negative and a negative gives us that, which means we'll have 3y, if we subtract this on both sides, equal to negative 8. Therefore y is going to be equal to negative 8 over 3, and that is as simple as that gets. As for how our mark allocations work, well, for adapting this equation number 3 and then actually acting on it, those are those marks. Then you deserve a mark over there, and one for our final answer as well, and then this entire setup. So those are the 5 marks. Might be slightly off with the allocation and the distribution, however it's in general pretty accurate. Now this question asks basically that we have this term stated in terms of a and b. So at the end of this, everything should just be a's and b's, whether they are squared, whether there are coefficients involved, that doesn't matter. Well, to begin with, let's just rewrite what we were given, which is 2x minus y. And then we'll just do basic substitution. So that's just 2. Well, what's the x value? That's none other than a plus b over a minus b. And then subtract. Our y value is a minus b over a plus b. So we have fractions inside those brackets to simplify. Well, a plus b multiplied by a minus b, if we use our brackets, that's just going to be a squared minus b squared. So that's that. Now we'll turn to our green color over here, because this fraction needs to be multiplied with a plus b, so we'll have a plus b all squared minus, and then the same needs to happen for this one. Over there we'll have a minus b all squared, and close our bracket. Now comes the hairy part. I owe this b an exponent. 1,000 apologies. So that's a squared minus b squared. Well, if we expand the first bracket, we'll have a squared plus 2ab plus b squared minus, open a bracket for safety's sake, and then we'll do this expansion, which is a squared minus 2ab plus b squared. Feel free to double check my expansions over there. In fact, I recommend it. Back to fraction, so we'll have a squared minus b squared as our denominator still. Now let's have a look. A squared and then minus a squared, that's going to zero out. Me and dropping exponents, that is bad. B squared minus b squared, well, that zeroes out. Now we have to remember that a negative and a negative gives us a positive, and 2 plus 2 is nothing other than 4ab. Wow, that numerator has a lot of space. Space I could have used in any case. So the simplification of this at the end of the day is just 2 times 4 gives us 8ab, and at the bottom we'll have a squared minus b squared, and that is in terms of a and b. As for marks, let's have a look. Substitution, well, all the expansions and simplifications, and then your final version of the expression gives you the final mark. Now over here we're being given a sequence, so in the sequence we investigate first. If we have a look, 14 minus 5 gives us 9, 23 minus 14 also gives us 9. So we know it's linear. Now from that we can just add 9 and add another 9, and that'll give us the values 32 and 41. Now it straight up asks us to calculate the 25th term. Now for that we need the general term first. Now all we need to do is take that 9 in, that 9, and multiply it with an n. Now if we have the first term, 9 times 1. We already know what the first term is. Well, how do I get from 9 to 5? Well, I have to subtract 5 to find that out. The answer is 4. Well, that means I have to subtract 4 to get to 5, because that's the difference between 9 and 5. So that's our common difference, and that is one of the easiest mechanisms, mentally speaking, just to make sure that we get the correct general term. So more specifically, we will ask for term 25, and that's just 9 times 25, as we substitute 25 into n, and then subtract 4. Final answer for that is then 221. Double check my calculator work. Okay, so for that we were allocated 3 marks. Such general term, substituting 25 in there, and the final answer as well. And we move. Now let's have a look at this diagram. As we can see over here in this diagram, it's a bunch of crosses. So this one has 5 blocks. The way they expand it is with the blocks at the end. So if I bring that into there, and then look at the second expansion, well, they're just adding 4 blocks every time at the ends of the crosses. So that's good news. That's simple. So how many squares will pattern 5 have? Well, this is 5, and as we saw, plus 4, that gives us 9, plus 4, that gives us 13. So number 4 is going to be 17, which means pattern 5 will have 21 squares. It's probably the ugliest handwriting that I've ever delivered. So, make a conjecture, an opinion, a theory. No proof required about the number of squares in any pattern. Well, the first pattern has 5 squares. Then add 4 for every subsequent pattern. Now your sentence does not have to be this complicated. It does, however, need to make sense in the English language, and your marker will look kindly upon you. Ta-da! Write down an algebraic statement to generalize the relationship between the number of squares and the pattern number. Now, like we stated previously, what you have to look at first is the difference between the patterns, and the difference is 4, so we add an n to that. So how do we get to 5? Well, we just add 1, because we make n equal to 1. Again, to make sure that our general term or our algebraic statement is correct, we need to make sure that this pattern can generate the first term. So the first thing you look at is the difference between them, and we saw that's adding 4, so that's where the 4 in the 4n comes from. Then we must generate the first one. So how do I get from 4 to 5? I add 1, and that completes this general rule. So how many squares will pattern 15 have? Now I take that, substitute the n with a 15 on the left, and when I do on the left, I must do on the right. That's just 61 squares. Slightly better in terms of handwriting. Maybe we can improve even further. Let's see. And boom, question 4 delivers to us some graphs. You need a color that stands out against the white. So can I have my there, and we're back. So for this, we can see that f of x is our quadratic function or our parabola. So that's f, and this is obviously g, the straight line as defined by x plus 2. And then we can see we have some intersects with the axes A, B, E, and C. We have points of intersections between the graphs. Well, A doubles is that. Then there are some line segment IJ over there, and also FG over there. I don't know how important whatever is. Let's find out. So, first question. Determine the coordinates of A and B. Over there and there. And we can see that they are x coordinates. Right. Or x intercepts. Sorry. So, in terms of f of x, for x intercepts, we make y is equal to, we set y equal to 0. Why do we do that? Because the x axis in our Cartesian plane is defined by the equation y is equal to 0, quite simply because the y value at any point on the x-axis is equal to 0, because that's how we read it. It goes through the point 0 and 0, which we call the origin. Enough about that. So we didn't thumbsuck this theory. That's the reason we do it. So we are going to set x squared minus 4 equal to 0. We know how to factorize that. That's just the difference of squares or perfect squares. So that's x plus 2, x minus 2. Therefore, x is equal to negative 2, or x is equal to positive 2. From that factor, and that's from that factor. Now that's not enough. They want coordinates. So let's give them coordinates. So the coordinate of A is the negative x value, which is minus 2, but it has a y coordinate, which we used. So that's minus 2 and 0, and that makes B obviously 2 and 0. And that is properly answering the question. So for factoring and using our standard form ideas, then obviously set up answers and then answering the question actually in the format required. Remember, they ask for coordinates, so give them coordinates. Now they want the length of EC. So, well, that's C and that's E. Well, C is the y-intercept of the straight line g of x, and E is the y-intercept or vertical movement from the origin for the parabola, and that's at 0 and minus 4. So C is at 0 and 2. So EC is just going to be equal to the biggest value, which is 2, minus the smallest value, which is minus 6. So that gives minus 4, sorry, that gives us 6 units if calculated correctly. And to my mind, that's worth 2 marks. Understanding the calculation and actually doing the calculation. Now they want the coordinates of D. What is D? Well, D is one of the two intersections of the two functions or the two graphs. So what happens here? Well, over there at D and over here at A, those points are shared between the two graphs. Let me repeat that. Those points exist on both graphs. Now that is the visual. What is the algebra of that? Well, that means those are points. If the graphs are equal to each other, then the equations must be equal to each other. And that is what we do. So visually we have equality. You can see an overlap and a complete overlap or congruence between the 2 points. So we need to have the same equality in the algebraic definitions. From here, we just need to set this in standard form. So we'll subtract x from both sides. So we'll have minus x, and then we subtract 2 from both sides as well. So that zeroes out, that zeroes out. This becomes minus 6, and that's all equal to 0. Now that we have standard form, we can just factorize, and that becomes x minus 3, x plus 2, and that's all equal to 0. Therefore, we have x being equal to 3, and x being equal to negative 2, but we don't need both. We now need to interpret the results we have. Well, we know that that is minus 2 and 0 from our previous question, where we did the coordinates of the x-intercepts. However, this one here has a positive value, and that's the positive value. So now we just need its accompanying y value. And like I said, d exists on both, so the easiest way is to calculate for g of 3, which is just 3 plus 2. Why 3 plus 2? Well, I substituted the value 3 into this x, so it's 3 plus 2, which is equal to 5. And now I have a y value for the x value 3. Therefore, the coordinates of d are equal to 3, and it has a y value of 5. And graphically, that also makes sense. So I am very happy with that. So setting the equations equal to each other, that gives you a point. Gives you a mark. Getting them to standard form, factorizing, getting your answers, and then finally answering the actual question with a set of coordinates gives you full marks. Maybe we can change our color, make it slightly darker, lighter, I don't know, darker. So if k has coordinate negative 4 and 0, determine the length of ij. Well, how do we do that? Well, firstly, let's just have a look. They are telling us the coordinates of k. K has coordinates minus 4 and 0. Now that minus 4 is the interesting bit over here, because it gives us an x value, which becomes the x coordinate over there on f, and it's also the x coordinate over there on j. Now to determine this length ij, I need y values. I need the y value at I, and I need the y value at j, which means I need ij. I know that ij is going to equal, well, what's the top value? F of x minus g of x in general, but we're not talking in general over here, so let's get more specific. I need the y value at minus 4 on f minus the y value at minus 4 on g. So that's quite interesting and easy to calculate. So I sub minus 4 into there, so I get minus 4 all squared minus 4, and I can subtract minus 4 plus 2. That takes care of g of x, because I had substituted negative 4 in there as well. And then this becomes a, well, you can do it with a calculator if you choose. 16 minus 4 gives us 12 minus 4 plus 2. That's just minus 2. And drums please. It should be 14 units straight up. That is good to me. What does the memo say? It agrees fully. It should be full marks. Completely. Right. Next up. Well, we are being asked, firstly, well, I have a nice set of black, a black Cartesian plane with a nice set of axes over there. Well, first thing they ask, sketch the graphs of f and g. Well, let's start with g, because it's easy. It's just a straight line. Well, we know it is gonna go through the y-axis at -3/2, which if you use your calculator is going to be right over there, because that's -1.5. And if we calculate the x coordinate, or the x-intercept, then we just need to put this equal to 0, which means that it's going to become x equal to 3/2, which is going to have a similar fate. It's going to be over there, and then I can use a straight line. Well, that has 45 degrees. Let's see, do I have that line? That should do it. Oh, not bad, Mr. K. Not bad at all. Well, we need to do the calculations for our parabola first. Okay, so first things first, -9/4. Well, that is going to be somewhere over there. However, because that's our Q value, that's easy to read. We know this is positive, so if a is greater than 0, we know we have a smiling parabola. Now let's put x squared -9/4 equal to 0. Well, we have two options. We can factorize as is, because 9 is a square and 4 is a square. So we'll have x squared, not x squared. I'm trying to factorize correctly, my bad. So that'll be x plus 3/2, and then x minus 3/2, all equal to 0. Therefore, x is equal to -3/2, or x is equal to 3/2. And obviously the accompanying y coordinates over there is going to be equal to 0 and 0. So 3/2, well, that's nice. That's also good. And then on the side, also -3/2. So let's see if we can sketch a decent looking parabola. Okay, just some rough lines over there first. Oh, hopefully this is not going to end up being too bad. And then it needs to turn and go up. Not the best, not the worst either. There, ladies and gentlemen, all I need now to add in some values, and you will be judged on shape. So just draw some construction lines first and get that. As far as marks go, well, having the correct intercepts get you some marks, and making sure that the parabola is in the correct shape and the straight line goes in the right direction. That should give it to you. Hopefully that was informative and not too boring. Right, so for the range of f, let's do that first. Well, the range is all the valid y values, and we can see that the y values for the parabola go from this turning point over here, and then they go up, or they increase. There are no y values for f below the parabola, obviously. So therefore y is going to be greater and equal to, what's its minimum value? -9/4. And remember, y is a member of the real values. The domain of G, well, that's just, well, where's all the valid x values for G? Well, Remember that was for f. And then for g, our domain is just, well, all the x values count. Every real value on the number line is part of the domain of g. Yeah, forgot to label that. And that's obviously if. Now, for which values of x is f of x less than g of x? And that was a 2-mark question. Now, you could go and do the calculations. I would not recommend that, because for 2 marks, you're supposed to read those off. And as we can see, this is the part that satisfies this kind of inequality, that being less than. So we want the part where f is less than g. Visually, we want the part where f is under g. And again, I'm going to trace over this white part with some orange again. So another important but is they want values of x. So the answer must include x. It must say x is equal to, x is less than, or something like that. In this case, x is in between two values. The first one's easy to read. That's point of intersection, which is 3/2. The second one, well, if we drew our graph not too badly, well, we can see that's roughly -1/2, and that's what I'm going to accept. So x is in the middle, -1/2 is the one extremity, and the other one is 3/2. And remember, if we do that right, smallest value on the left, biggest value on the right, then our inequality signs always go to the left. I am not going to do a Beyonce interpretation or impersonation. Maybe that reference is even aging. Go ask your older cousin. Right, if f is moved down 3 units, what is the equation of the new function? So let's remember that f of x is equal to x squared minus 9 over 4. Well, for the new equation, we're going to have x squared minus 9/4 minus 3. Why minus 3? Down 2 units. Okay, why are you so down? Why are you so negative? So I'm just moving it down. So some quick calculator work. So new equation is just going to be x squared minus 21/4, and that is it. Literally worth 1 mark. Section B. Well, we are moving, aren't we? Radio. I think yellow is good for this. Solve for Q to 1 decimal place in the diagram below. Where's Q? Q is there. Now, if we have a look at the bottom triangle, well, we just have an angle, and then we have P and no other values. And then if we look at the top triangle, well, we still have that. So, well, what do we do? Well, let's see if we can set up equations anyway. Okay, so first things first is we look from the point of view of 11.55 degrees, and we see that P is opposite, and we see that Q is the hypotenuse. And when we have the opposite and the hypotenuse, we know that's a sine ratio. So given that I'm going to need a lot of space, first let's get rid of this. Now that we know what ratio we have to choose, so we're going to say that sine of 11.55 degrees is nothing other than P over Q. Then we look at this, the second triangle, and we see that, well, that's opposite and this is adjacent. Opposite over adjacent, or opposite and adjacent, should remind me of tan. So for that, we can say that tan of 21.8 degrees is equal to, well, P plus 2 over Q. Well, what tools do I have to sort this nonsense out? Well, if I set both equations and make P the subject of these equations, what I then have is a way to eliminate P. So let's get to doing that. So for our sine equation, I'm going to multiply both sides by Q because that eliminates the denominator on the right hand side. And I have P equal to sine, or Q, let's do that right and a bit neater, is equal to Q sine of 11,55 degrees. Rightio. And then for this equation, let's do the exact same thing. We'll multiply by Q on both sides, which will have us Q multiplied by tan of 21,8 degrees, and then we can subtract the 2, and that'll give us P. So now we have P and P both in terms of Q, which means we can take the left hand side of this equation and the right hand side of that equation and make a new one, because they are equal to each other. They are both equal to P. They are both equal to P. So we can say quite confidently that Q multiplied by tan of 21,8 degrees minus 2 is equal to Q multiplied by sine of 11,55 degrees. Now we have a linear equation with some trig thrown in. So let's just do some swapping in a different color so we don't get lost. So Q tan times tan of 21,8 degrees, and then we subtract or transpose that expression. So that's Q multiplied by sine of 11,55 degrees, and then obviously just add 2 to both sides because we want this to zero out. Now on the left hand side, we can factorize Q, and we'll have tan of 21,8 degrees minus sine of 11,55 degrees, all equal to 2. Therefore, drums please, Q is going to cause some calculator work. Well, we're going to divide by that, which is just none other than tan of 21,8 degrees minus sine of 11,55 degrees. Punch that in your trusty calculator, and you'll get something like 9,969. Well, if rounded off to a whole number, Q is equal to 10. And then even if rounded up to 2 decimal places, for 2 decimal places you'll have 9,97, but generally speaking they want 1 decimal place, which is going to cost 10,0. Now as far as the mark allocation goes, well, let's see, that's worth a mark, that's worth a mark. Both are setups, and then setting up, equating those two equations, simplifying, and getting to your final answer. This is obviously just one way. There's a different way or two in which this problem can be approached as well. Mark allocation, distribution might differ, but the allocation will be the same. Now, 2 grade 10s are trying to use their trigonometric skills to determine the height of a tree. Ooh. Don't they have Xbox or YouTube to watch? Why would they want to determine the height of a tree? Well, they are standing 40 meters away from the base of the tree. SIPO has measured the angle of inclination of the top of the tree to the top of the tree to be 36.9 degrees. So this is the incline he sees from where they stand. So first things first, let's just see if we can determine the height of the tree. Well, the height of the tree, if I can throw it in, maybe some purple, will form this side of a right angle triangle for us. So from the point of view of C4 then, and this 36.9 degree angle, the height of the tree represents the opposite side, and this 40-meter distance away from the base of the tree represents the adjacent. When I see these, I know I'm dealing with the tan ratio, but it has to be applied to an angle, in this case 36.9 degrees. And what am I trying to calculate? Well, instead of calling it O, we'll call it the tree height, and the adjacent side is 40 meters. Well, to resolve this is quite simple. Just multiply both sides by 40, multiply by 40. That's the cancellation I want to cause. Therefore, H is alone on this side, and on that side we have 40 times tan of 36.9 degrees, and that'll simplify to the height of the tree being 30 meters to the nearest meter, obviously. Right, now if both learners move forward by 10 meters, well, so we've established that that is 30 meters in height. Now, if both learners move forward by 10 meters, now this diagram is obviously not drawn to scale, that means 40 minus 10 meters is equal to 30 now. So this distance will be 30 meters. What do they want? They want the new angle of inclination. So they want this angle. Now, obviously this is a right angle triangle, which means the sum of these two angles is 90 degrees, and the new angle of inclination is equal to 45 degrees. That is just basic geometry. There is no need for a trigonometric calculation, although you could do one if you so choose, but just the answer is worth 2 marks in my book. Now we are considering a diagram, and we're considering it below. Well, it's in the third quadrant. We have a theta, an angle over here, and we have P with a set of coordinates. So if we transpose these values, we know that's going to be -4 and that's going to be -3. And I might as well do my Pythagorean calculation. So if we call this R, we know that R squared is equal to -3. That 3 can be a lot better. I promise you guys. -3 squared plus -4 squared, because Pythagoras and his dudes figured it out a long time ago. So that's going to be 9 plus 16, because that's squared. Therefore R squared is equal to 25. Thusly R is equal to 5. Well, we've got that figured out. That's good. Let's go hunt for some questions. Well, first things first, without the use of a calculator. They want the value of cotan of theta. What did we say? That's -3 and that's -4. That is 5. Well, cotan of theta, well, cot is the reciprocal of tan, and tan theta is opposite over adjacent. So over here we're going to work with adjacent over opposite, and that we just read off of the diagram. So what's the adjacent side? -4 over -3, so that's -4 over -3, which is just going to be equal to 4 over 3, because a negative divided by a negative gives us a positive. Well, that's going to be 1 mark, and remember, you still have that R calculation, which also gives you a mark. And I think there are 3 marks to be distributed over here. Yes, one's going to be for realizing what cotan actually is. Let's do. Apparently I made a numbering error, but if you number it C, that's fine. number it B and corrected my error, that's also fine. Well, back to the maths. Well, tan squared of theta plus cosec of theta is just going to be equal to, well, we already established what tan is, so that's opposite of adjacent. Let's read that off. So that's minus 3 over minus 4. However, tan was squared, so this ratio must also be squared. Now, we know that sine of theta is equal to opposite over hypotenuse. However, cosec theta is its reciprocal, which means it's going to be the hypotenuse over the opposite side. So let's mark it as such. What is the hypotenuse in this case? It is 5, and that is just over negative 3. Let's resolve this. That will be well, tan squared is going to be 9 over, because that's opposite over adjacent, 16 opposite over adjacent, yeah, that was good, plus, or not plus, because a positive and a negative, when multiplied gives us a negative, 5 over 3. Let's see if we can resolve this mentally. That's going to be 16 times 3 is 48. Well, we have to multiply by 3, so that becomes 27. And then 3 to get to 48 becomes 16. Okay, so minus 5 times 16 is minus 80. Give me a sec. That's minus 53 over 48. If that serves, calculator checking would be good from you guys. Let me know in the comments if I got that right. Well, calculate sine of 60 degrees, cosec of 30 degrees, and tan of 45 degrees. Well, those values in the rotations or angles should look familiar. Well, they come from our special triangles. So let's see if we can draw them. So we have an easy time referencing stuff. There we go. So that's a 30-degree angle. Should remember, go across 1, 2, 3, but the square root. And then for the 45-degree angle, we have 1, 1, and the square root of 2. We might as well add in the 60-degree angle over there. Now referencing becomes easy. Therefore, sine of 60 degrees plus cosec of 30 degrees plus tan of 45 degrees simplifies to, well, what's sine of 60? You can have a look. Opposite over hypotenuse. So that's the square root of 3 over 2 plus cosec of 30. Well, cosec is the reciprocal of sine. So it's not opposite over hypotenuse. It's hypotenuse over opposite. Well, from 30, hypotenuse over opposite, well, that's plus 2 over 1. And the last one, plus tan of 45, opposite over adjacent. So that's going to be 1 over 1. Well, simplifying this further, we still get square root of 3 over 2. Plus, if you want to put this over 2, it's times 2. What you do at the bottom, you do at the top. So that's going to be plus 4 over 2. And then plus, well, same thing here. Well, why are you multiplying by 2 at the top and bottom of all the fractions? Because this one says 2, and we want a common denominator. And there we have that. So our common denominator is 2. Then we have 4 plus 2 is 6. Plus square root of 3. And that's good enough for me, because that is a single fraction as required. So 1 for the ratios, 1 for simplification, and 1 for our final answer. Let's move on. Right. That one is just inverse sine applied to 0, 2, 3, 4. What do I mean by that? I'm talking about the theta. We are ripping the theta out of the sine ratio, and that is going to equal 13,5 degrees. Calculator work. How about B? Well, there's a reason you only get 1 mark over here. For B, we are going to divide both sides by 5. Therefore, we have cosine of x being equal to 3 over 5. And from there, again, we have the inverse of cosine applied to the ratio 3 over 5, which gives us an angle of 53,1 degrees when we round off to 1 decimal place. Mark allocation. I think that's pretty self-explanatory. Slight note on this, your examiner made a mistake over here which wasn't caught in time, so my apologies. However, it doesn't mean that the problem is unworkable. Let's have a look. Cotan is the reciprocal of tan, so there's no cotan button on the calculator, so we have to reciprocate on both sides. So tan of theta becomes, well, 1 over tan of 53 degrees multiplied by sine of 233 degrees. Well, that's just equal to, from theta's perspective, inverse tan of 1 over tan of 53 degrees times sine of 233 degrees. And your calculator is gonna be very angry with you because it's gonna give you this result, 43,3 degrees, but negative. And again, I do apologize profusely. You're gonna have to be accepting of that value, as am I. Yeah, given the mess up, I might have missed a comma somewhere, or maybe just added an extra 3. I'll go back and double check my source materials. Radio, and we are at our final stages as we hit Euclidean geometry. Quick note over here: if you guys at your specific school in your specific class have not handled Euclidean yet, you guys feel free to end the video here, or if you're still familiar with what you've done in grade 9 and you want to get a head start, that's also fine. If however you have started with some Euclidean, that's good, but remember, these videos are going nowhere. I will chop this up question by question, so you can always come back the day you do start your Euclidean journey for grade 10. That being said, let's get to it. Well, here we have our diagram, and it's obviously a parabola because we can see we have 2 sets of parallel and equal sides. Well, the parallel is quite obvious, so let's just have a look at what we can do with this diagram. Well, obviously that's a nice isosceles triangle, so that's going to be equal to x. Well, this is 180 degrees minus 2x, and given that those are parallel, that's going to be 2x. That's also going to be 2x. This is slightly fun. Ooh. That's going to be 2x. Yeah, this makes sense. Anyway, let's see what they want from us. Solve for the angle marked x. Let's see, did I leave space for the solution? Yes, I did. Okay, well, let's get to it. Need to mark the guideline because I did preparation. Well, first things first, I'm going to say that angle AFD is equal to x, which is this one over here, and that's quite simply equal angles opposite equal sides. From there I can then say angle A over here is equal to 180 degrees minus 2x. Well, that's just the angles, or the sum of the angles in a triangle, in this case triangle AFD. That would make angle B, like we did in the previous slide, equal to 2x. Remember, this is 180 minus 2x. And why can I say that? Well, because they are co-interior angles between the parallel lines AD and BC. Now, that means I can also say then that if BC, this angle over here, is also equal to 2x, same reason I used here, equal angles opposite equal sides. Well, now I have enough information to figure out the value of x, because I've put them together in such a way that they are on a straight line and coming from different sections of the figure as a whole. So I'm going to use, quite simply, just a straight line equation, and then I'm going to say that x plus 28 degrees plus 2x is equal to 180, given everything that I've proved in here. Say angles on a straight line. Well, this means we have 3x, because I just added those, being equal to 152 degrees. Thusly, x is equal to 152 divided by 3, which is just going to be 50.7 degrees if we round it off to 1 decimal place. Well, mark allocation over here is a bit tricky. But the statements and the reasons should be worth 3 marks. 4th mark will go to setup of your final bits of reasoning, and then your final answer should give you a final mark. Do not take my mark distribution as the gospel truth. Question it by way of your teacher. In this diagram, we have BCDE and AODE as parallelograms. Parallelograms. Just having a bit of fun over there. So that's BCDE. So we're going to mark those. There we go. There we go. And then AODE. Need a new color. Here's A, here's O, here's D, that's E. So you get our green back and understand that that is also a parallel line. And then these three. So that gives us a bit to work with. Let's see what they want in terms of questions. Ta-da! Let's see if we can get our markings back. Right, so we know that that line is parallel to that line, and then obviously let's give the triple arrow to the longer sides. That's going to be parallel over here, and because it's a different parallelogram altogether, smallish one at that, we'll do that. So let's see what is required of us. Well, they want OF. That line segment over there to be parallel to AB, which is that line segment right over there. Let's see how we shall accomplish this. Well, we do have that OB is equal to OD. Let's see if we can follow this. And then OD is also equal to AE. Right over there. So let's address the first part. Well, OD is equal to OB because the diagonals of a parallelogram bisect each other. So we know that. Then we can also say that OD is equal to AE. Well, because AODE is already a parallelogram. That was given to us. Now what that means for us right now is that that line segment we can deduce then is equal to that line segment. How does that help us? Well, that helps us because OD or BO, this entirety, because it's a straight line, it's a diagonal, is already parallel to AE. Why? Because again, AODE is a parallelogram that was given to us. That means that AOBE or ABOE is a parallelogram. So don't preempt. Now some of you are already seeing something. So let's just go with it. So we are going to say OB is equal to OD, diagonals of parallelogram. And then we can also say that AE is equal to the selfsame OD. Now, opposites sides of a parallelogram. Therefore, OB is equal to AE. And we straight up say that OB is parallel to AE. Again, opposite sides of a parallelogram. Given one. Now, what do we have here? Well, we have the opposite sides of a quadrilateral that are both equal and parallel. So therefore, I can say that ABOE is a parallelogram. Why? One set of equal and parallel sides. Now that immediately makes that line segment parallel to that line segment, and that is my conclusion. Therefore, OF is parallel to AB. Now B, prove that ABOE is a parallelogram. Well, see above. Right there. Okay, B. Radio. So quite a lot of work and extra work to prove that OF is equal to AB, and then that leads to virtually no work for all the marks in B, as long as you mark the section in your reasoning at A as B as well, and then you can direct your marker's attention to the work that you have so lovingly created for them. final one. Now they want triangle ABO to be equal in shape and size to triangle EOD. So let's have a look at ABO. That's ABO. Alright, and where's triangle EOD? Well, that's triangle EOD. Well, let's just give it to them in triangle ABO and triangle EOD. I can comfortably say that AB is equal to OE because they are the opposite sides of a parallelogram, the one that I just proven, ABOE. And then the next one is going to be AO being equal to DE. Well, those are the opposite sides of that given parallelogram. And then finally, I can say that OB is equal to OD. Why? Because they are the diagonals of the big palm. And those bisect each other. Therefore, triangle ABO is congruent to triangle EOD. And our congruency condition is side, side, side. That, dudes, is it. That's the whole thing. Done and dusted. Hope to see you guys again soon. Getting back to general stuff and some other preppy stuff as we continue to journey to increase our skill in learning and teaching. Remember, I also have to get better at this. I can't stay at one standard. If I'm sucking currently, hopefully I'll get better. And if you think I'm worthwhile, hopefully I'll get super. For now, keep learning. Don't suck. Be awesome.